The Su-57 is categorized as a fifth-generation fighter, recognizing that it will make use of the latest aviation technology, radar-absorbing materials, and weaponry to provide for excellent performance, agility and response for the unseen conflicts ahead. As a fifth-generation fighter, the Su-57 is challenging the realm currently dominated by the American Lockheed F-22 Raptor air superiority fighter, the world's first fifth-gen fighter aircraft. The arrival of the T-50 introduces a second player to the once exclusive fifth-generation club, owned wholly by the United States, while China continues development of their own indigenous fifth-gen fighter across the Pacific. In the Russian, PAKFA translates to Future Air Complex, Tactical Air Forces. Serial production for the T-50 is slated for 2015, and the first public unveiling of the prototype was shown during the MAX 2011 air show just outside of Moscow in August of 2011. By the end of the Cold War, the need to replace Russia's high-performance do-everything fighters became more apparent to authorities. Several projects were enacted to find solutions for a next-generation craft, and two such programs produced the Mikoyan MiG-1.44 and the Sukhoi Su-57 Berkut. The MiG-1.44 became a highly secretive technology demonstrator and achieved first flight on February 29, 2000. She was intended to compete directly with the American Lockheed F-22 Raptor in the air superiority role. The MiG-1.44 sported forward canards with an under-fuselage split air intake similar to the Eurofighter 2000. The Sukhoi Su-57 Berkut was the other technology demonstrator, though it had the greater possibility of seeing full-scale production. Most notable of the type was its forward swept-wing arrangement, a la the Grumman X-29 concept, and decidedly large Sukhoi brand dimensions. Only a single known example of the Su-47 was ever built, while two examples of the MiG-1.44, the other being the similar MiG-1.42/42, was known to exist. Both were powered by a dual-engine layout, and much information garnered from the preceding in-flight tests have played a role in the development of the Su-57. In the early part of 2002, Sukhoi was selected to head up the design of Russia's new fifth-generation fighter. By the start of 2003, other minority contract winners were announced to design, develop and construct applicable components such as the avionics suite and engine power plants, as well as the understructure and final assembly systems. Production of the very first aircraft was started by August 2007, with the goal of having 3 such flyable systems on hand by the beginning of 2009. Core components. The Su-57 makes use of radar-absorbing materials to achieve its stealth, as well as onboard counter systems and structural design. The engines allow for supercruise travel, achieving supersonic flight without the need for thirsty, radar/missile attracting afterburner, also known as reheat. The Advanced Active Phased Radar Array, APRA, system is being developed by the Phasatron NIIR Corporation and will offer both forward-looking and side-scanning capabilities, similar in scope to the Airbus radar found on the Sukhoi Su-35BM flanker. The complete system, involving multiple linked radar systems, is being tested on an existing aircraft, though not a T-50 prototype. Capabilities will allow for the tracking and engagement of multiple targets simultaneously, be they ground or air-based. The cockpit will be all glass in nature and digitally minded compared to any previous Russian offering. The onboard computer network will actively work to correct in-flight stability issues and help the pilot by reducing workloads. The wings have been given leading-edge flaps which handle lift at higher angles of attack while being completely adjustable as the aircraft's speed dictates. Ailerons will support low-speed flight and handling, while flaperons will assist in low-speed lift on approaches or takeoff.